Hello everyone, welcome to Coders Camp. So in this video we are going to cover another problem from LeetCode weekly contest, which is minimum speed to arrive on time. So the input given here is an integer array and an integer variable hour, which represent the maximum hour you get to reach to your office. So this distance array is nothing but the integer values that represent the distance at each stop in kilometers, and we have to return the minimum speed needed to travel through these stops to reach your office within this time limit. So let's understand this problem with an example. So here is a given input array where we have given an integer variable hour, which is 6, which is nothing but you get maximum of 6 hours to reach your office. So to reach your office you need to travel in 3 trains, and each train travel 1 kilometer, 3 kilometer and 2 kilometers respectively. So overall 1 plus 3 plus 2, which is 6, you have to cross 6 kilometers within 6 hours. So now, at what speed if you go, you will reach your office on time? That is the question. So consider you are traveling by 1 kilometer per hour. So in that case, within the first hour, you will reach your or finish your first train. By moving on to the station 2, which is going to travel for 3 kilometers, so you are traveling at 1 kilometer speed per hour. So in that case, in next 3 hours you will complete the station 2. So first station will be covered in 1 hour, second station will be covered in 3 hours, same way the third station will be covered in 2 hours. So in total you will reach exactly to your office in 6 hours. So that is going to be your output. So how are we going to approach this problem? So we know the minimum speed for any problem or any example is going to be 1, because in problem statement they said that speed is a integer value. For any integer value the minimum speed it can travel is 1. Same way the highest value of speed is given as 10 power 7 in the problem statement. So if we know the lower bound and upper bound of our output, that is our output is definitely gonna be between 1 and 10 power 7. In this case we can approach this problem using binary search. So if you have watched our videos on binary search template and other problems we have solved using binary search logic, you must be familiar with our binary search template we have used for every binary search problem. So here also we are going to use the same template or the same code to achieve this solution. So in our template we are going to fix the left and right values first, and we are going to call a condition function, and based on the result of this condition function we are going to set our limit to either from left to mid or mid to right. So which is again a pretty simple logic of a binary search. Based on the result of this condition function we are going to set our limit and again perform the same operation till we find our answer, and finally we are going to return our left as our result. So before getting into how our condition function is going to work in this problem, there is one more scenario which is a negative scenario. That is, if we cannot reach on time, then we have to return minus. So there can be a chances that we cannot reach to our office only if the total hours or the total distance is greater than the given hour, because the minimum speed you can travel is 1 hour per kilometer. So in that case, if you are trying to travel all your destinations in 1 hour, the minimum time it is going to take is sum of this distance array. If our given hour is greater than its sum, then in that case it is a negative scenario. Then we are going to return -1. If not, we are going to apply our logic here. So what does our condition function do in this problem? So first we are going to set a lower bound and upper bound to these values and pass our mid value to our condition function. So here the mid value is nothing but the speed we are checking. So this condition function is going to check by using the passed speed, that is our mid value, whether we can reach our office within the maximum hour. If we can reach, it is going to return true. If not, it is going to return false. And based on this value we are going to set our limit to left to mid or mid to right +1. If suppose by using this speed we can reach our office within the hour, which means we can reach even in the lesser hour. So we are going to check whether we can reach to the office even in lesser hour. So we are going to set it from left to mid. If not, if it returns false, which means the time is higher, we couldn't reach our office within the maximum hour, in that case our speed is less. So we have to increase our speed. So we are going to set our limit from mid to right plus 1. So let's go for a very quick dry run before getting into the coding part. So for quicker execution, let's not consider 10 power 7 as the higher limit. Let's say it is 10. So now our left is 1 and right is 10. So let us have our mid value as 5. So we are going to pass 5 to our condition function to check whether we can reach our office by using the speed 5. So now our first distance is 1. So we are going to calculate a time variable, and at the end we are going to compare our time with the total hour. So we are going to calculate time using the formula distance by speed. So distance here is 1 kilometer and the speed is 5. So first we are going to check 1 by 5, 3 by 5, 2 by 5. So here one thing to note is in problem statement they have mentioned if we have reached to other station in 0.5 hours, then it will not start until the next integer number. That is, we have to wait for one more 0.5 hour in order to start our train journey, second train journey. So first 1 by 5 is going to be 0.2. So anyway, we are going to wait for 1 hour completely to start our next train. So it is going to take 1 hour, and 3 by 5 is going to take again one more 1 hour, and another 2 by 5 is going to take again one more 1 hour. So now we can complete this journey in 3 hours. So actually, which is less than our maximum hour given. So we can travel with the speed 5. So we are going to set our limits to 1 to 5. So now again calculate the mid value, which is 3, and check whether we can reach in 3. And further shift our limits based on the output the condition function gives, and finally wherever we stop at a value, that is the actual speed we needed, and we are going to return that as an output. So this is going to work in log n time. So n here is nothing but 10 power 7, as we are going to reduce the value by half every time. So let's go to the code now. So let's start by checking the negative scenario. If the length of the distance is greater than the hour, then we cannot reach that office. So we are returning -1. Other than that, we are going to set our left and right limit and gonna have the same template we have used in our previous videos. So based on the condition function, we set our limit and finally return left, that is going to be output. So let's spend some time in writing a condition function. So we are passing our speed, distance and hour as a parameter, and we are going to calculate our time using the formula distance by speed. So we are checking one more condition using the modulo to check whether it has the remaining time, so that we have to wait till the next integer. And finally convert that to a double and return if the time is less than or equal to the maximum hour. So that's it. Let's run and try. So yes, let's submit and try. Yes, the solution is accepted. Hope you enjoyed watching this video. If you like the video, hit like, subscribe and let me know in comments. Thank you.